Okay, so today we are going to start unpacking a new topic, and this is the topic of algebra. Now, often when algebra is taught, students are kind of given the following phrase to learn and pretty much to repeat, and this is that like terms can be added or subtracted together. So if we have, say, 3x plus 2x, that gives us 5x. That is kind of the bare bones thing we're taught in algebra. Now, in this video, if you've watched me before, I really want to unpack this slowly and understand why this even works to begin with. What does this even mean? Now, breaking this down, what do each of these terms here have in common? Now, some of you at home may be able to point out that each of them contain an x here. And now, in algebraic kind of notation, this is like saying 3 times x, or 3 lots of x, plus 2 lots of x equals 5 lots of x. So we are dealing with products here. Now, before we even go on and talk about this, I'll leave this up here, but I'm going to go down and I'm going to just give you a little arithmetic kind of multiplication to do, because algebra essentially works off arithmetic, of our regular arithmetic that we do. It applies everything we know about multiplying real numbers, and he'll be looking at integers, and it applies it to unknown numbers. That's what these x's are here. Now, we don't know what x is, but we know that when we write a pronumeral, so one of these letters representing a number, x, y, z, a, b, c, whatever, these are just meant to represent a number. And because we have all x's here, we are talking about the same number here. Now, how algebra works is actually quite intuitive, because I'm going to just do something for you real quick. I'm going to give you a multiplication to do. So I'm going to say, what is 16 times 8? Do this in your head without a calculator. Now, often what people do when our numbers exceed our times tables, well, naturally what we're going to do is we're going to break up the bigger number, the one we don't really know as well. We know kind of factors of 8 here, but the 16, let's just break that up into two numbers we know. This is probably how you do it in your head as well. So I can make this out of 10 plus 6 times 8. And then I can do these multiplications separately and add them. So I'd say, well, I don't know what 16 plus 8 is off the top of my head, but I know what 8 times 10 is. That's pretty easy. Multiplying by 10 just gives us 80. And 8 times 6, well, I know that from my times tables. That's 48. And I'll just add them together. So that's kind of what we're doing in our heads, right? We're saying, well, all right, this is like saying 8 times 10. And let me do this kind of consistently here. Plus 8 times 6. And we'll get that this is 80 plus 48. The answer doesn't really matter, but let's just look at what we're doing here. Well, and let's see kind of what commonalities we have between what I wrote up here and what I have down here. So we will notice here that both my things here have a common factor of 8. 8 is multiplying by each of these numbers. And that is the same as these two pronumerals here. Now, what I just broke down here is I essentially broke up 8 times 16 into two separate sums. And we notice that 10 and 6, these add up to give us 16. That is why algebra works. We are doing the exact same thing that we did in our example above that we're doing when we say compute products of some kind. And all we're saying is that the left-hand side here is equivalent to the right-hand side. So I can express 8 times 16 as 8 times 10 plus 8 times 6. Now that would be no different to writing, say, 10x plus 6x. X here is just any number, pardon me, and adding two products here, because 10 is multiplied by some number x, and that's getting added to 6 multiplied by some number of x, that will always give us the sum of these two numbers multiplied by that same product. Whoa, sorry about that. Which gives me 16x. We can see some similarities. Well, we can see that the product is contained everywhere here in the same way that this common x is contained everywhere. Now, I said before x can be any number. Let's just try some insane number, right? Some really kind of big number. I'm not going to go too crazy with this, but let's say, just to prove to you that this will be the case in a lot of different, pretty much every case, let's say I wanted to find 10 times, let's say my x was 497. Let's say I wanted to calculate this. I'm willing to wager that this is going to equal to 16 times 497. And you can have a look on your calculators to verify this. I'm going to do it now as well. So 10 times 497, that gives us 4,970. And when added to 6 times 497, that gives us 2,982. And adding these together, we get 7,952. And I want to see if that is the same on the right-hand side. So multiplying 16 by this number, 497, that gives me the exact same thing. This is why algebra works. It works on the rules of arithmetic that we use kind of in day-to-day life. It works because the arithmetic works. And algebra pretty much just gives us a look at this through the lens of any numbers, any products here. Anytime we have, say, some number 10 here multiplying by x, and we add that to 6 multiplied by x, we can just add the coefficients, or by coefficients, I mean the number before the x. And adding those will give us this term on our left-hand side. And this is what they mean by we can add like terms. The like term is the number that is getting multiplied to each of our coefficients here. And that is why algebra works. So we can extend this to a number of different examples. Now that you understand why this works, and I know it was a long-winded explanation, but we can now compute any algebraic expressions. We can say, for example, we can find 7y plus 4y. Now, because we have the context, we can compute these pretty easily now. And the same works for subtraction. I'll talk about that more in the next video. But as for algebraic addition, we have looked at in this video why this works. And this is based on the rules of arithmetic that we have been approached to, and approaches that we have been, introduced to. And we also intuitively approach certain problems like this. If I were to give you some kind of large multiplication to do, say like this one, well, this one wasn't even that bad, but say even bigger numbers, we're naturally going to break this down like we did here. And this forms the basis of algebra. Understanding this and understanding that we can break down these numbers and add all of the separate products like we did here. This means that this can be extended to any number, not just the particular numbers in this question, but any number. And that is what we show by representing these things as x or y or a or b. Any pronumeral. We are showing that no matter which number I substitute into here, for example, here I did 497, we will always get this equivalence here, that the left-hand side will equal the right-hand side. And that is the basis of algebra. I'll see you guys next time.